Hello, good morning to all of the students. Today I want to discuss about the motion, force and work, the basics we have. So first we talk about motion. So what is meant by motion? A body is said to be in motion if it changes its position with respect to time and surroundings. Then we call it as the motion. So we have, for example, if a body is in motion, so if I am taking this pen from this position to this position, so it has moved from one position to the other position. Then it is said to be in motion with respect to time and surroundings. And here, if a body is said to be in rest, that means it does not change its position with respect to time and surroundings. So if I place a pen on the table, it will be at rest for so much time. So it does not change its position with respect to time and surroundings. Then we call it as at rest. So now in this motion, you should know the following definitions first. Basically, what is meant by distance, what is meant by displacement, what is velocity, what is speed, what is uniform velocity, what is meant by uniform speed and acceleration, uniform acceleration, acceleration due to gravity, and equations of motion. So in a quick manner, I want to discuss these definitions as fast as possible. So distance is the actual path covered by a body is called as distance. So it is measured in meters in SI system and it is a scalar quantity. Whereas displacement is the actual path covered in a particular direction. We call it as displacement. And it is also defined as the shortest distance between the initial and final positions of the body. And displacement is a vector quantity we have. And it is also measured in meters. So when we go for the what is meant by speed, the distance traveled per unit time is nothing but we call it as speed. Whereas displacement per unit time is called as velocity. And speed is a scalar quantity, whereas velocity is a vector quantity. And next we have the uniform velocity. That is, a body is said to be in uniform velocity if it travels equal displacements in equal intervals of time. Then we call it as uniform velocity. And we have acceleration. The rate of change of velocity is called as acceleration. And it is also a vector quantity we have. And next we have uniform acceleration. So a body is said to be in uniform acceleration if it covers equal changes in velocity in equal intervals of time. Then we call it as the body is said to be in uniform acceleration. So like this we can give the definitions for the what you call in motion. And we have quick revision for this we have displacement, distance, velocity, speed, uniform velocity, acceleration, uniform acceleration, so on and so forth. In motion topic we will discuss about all these things. And when we go to the force, we have three important laws we have in force. That is, one is Newton's first law of motion, second one is Newton's second law of motion, third one is Newton's third law of motion. So what is Newton's first law of motion? So every body continues in its state of rest or uniform motion unless and until it is expelled by some external force. So, or compelled by some external force. This we call it as Newton's first law of motion. So it mainly explains about the concept of inertia. So inertia, it is the inability of a body to change its state of rest or uniform motion by itself. We call it as inertia. And there are different types of inertias we have. Inertia of rest, inertia of motion, inertia of direction we have. And mass is the measure of inertia we have. And we have the Newton's second law. So according to this second law, it says that the rate of change of momentum is directly proportional to the external force acting on a body. So that is, F is proportional to dP by dt, or F is equal to m into V minus U by T, or F is equal to ma. So from the second law, we define the force, which is the product of mass and acceleration. And we have one of the famous laws is Newton's third law. According to this law, to every action, there is equal and opposite reaction. This we call it as Newton's third law. And action is equal to minus reaction. There are so many examples for the Newton's third law. That is, a rocket fired into the space is an example for the Newton's third law of motion. And finally, here I want to say about something about the work. So what is meant by work? So work is nothing but the dot product of force and displacement of a body is called as work. It is given by work done, W is equal to F bar dot S bar, that is equal to Fs cos theta, where F is the force, S is the displacement, and theta is the angle between the F and S. And we have different types of work done. That is, one is positive work, second one is negative work, and third one is zero work. So work is said to be positive if force and displacement acts along the same direction. That is, theta is equal to 0 degrees. Then we have F bar dot S bar is equal to Fs cos 0. So cos 0 is equal to 1. Therefore, W is equal to Fs. Then we call it as a positive work. And we have an example for the positive work is a body is lifted from the ground. And here, next type is a negative work. That is, force and displacement, they act in opposite direction. So then we call it as a negative work. So W is equal to Fs cos 180 degrees. Cos 180 is equal to minus 1. Therefore, W is equal to Fs cos 180, that is minus Fs. So work done is said to be negative there. So we have, when brakes are applied to a vehicle, then we have a negative work is done. And finally, we have the zero work. Zero work is when force and displacement acts perpendicular to each other, then we call it as a zero work. So W is equal to Fs cos 90. So theta is equal to 90 degrees. Therefore, W is equal to Fs cos 90 is 0. Therefore, W is equal to 0. Then that work is called as zero work. So when force is 0, or displacement is 0, or when theta is equal to 0, then we will have the zero work. So this is what I want to briefly explain about motion, force and work. Thank you.